Welcome to The Explainer. Have you ever looked at your garden or maybe even a farmer's field and wondered if there's some kind of secret ingredient to make everything grow better? Well, today we're digging into a really fascinating organic compound that might just be the key to unlocking some incredible plant growth. So let's start with the big question, one that really drives a ton of agricultural research. What if there was a simple organic compound that could basically hand a plant the key to its own engine, letting it unlock its absolute full potential? But before we get to the solution, we've got to understand the problem. And it's a huge one that growers face everywhere. It doesn't matter if you're talking about a massive commercial farm or just your own little backyard garden. Think about this for a second. Have you ever noticed this? You plant the same crop, maybe tomatoes, in the exact same spot year after year, and after a while, they just don't do as well. The plants seem, I don't know, weaker. They get sick more easily. What is going on there? Well, that's not just in your head. It's a real documented issue that scientists call the continuous cropping obstacle, and it is a major headache in agriculture. It wears out the soil and just makes it tougher and tougher to grow healthy, productive crops. Okay, so now that we've got the problem on the table, let's introduce our potential hero. It's a substance that comes from nature, and scientists are really excited about its ability to tackle these exact kinds of challenges. And here it is. This is potassium fulvate. Now, it's a type of humic substance, which basically means it's made from really, really old, decomposed plants and organic matter. It might just look like some simple black powder or flakes, but trust me, it is packed with compounds that can have a seriously powerful effect on plants. So what's actually in this stuff? Well, a lab analysis tells the whole story. Look at this. It is a powerhouse. You've got over 80% organic matter, it's loaded with active ingredients like fulvic acid, and it has at least 12% potassium oxide, which is a super important nutrient for plants. And maybe the best part? It's completely water-soluble, which means it's super easy for plants to actually absorb it. All right, we know what it is, but how does it actually work? To really figure that out, researchers had to get into the lab and see what it does on a biological level. So let's take a look at a really cool study that put potassium fulvate to the test. Now, what's so cool about this is the method. The researchers took corn seedlings, which are kind of like the lab rats of the plant world, and they gave them different doses of this stuff. They wanted to see exactly how it would affect the most basic, most important process a plant has, photosynthesis. And wow, the results are pretty wild. Check this out. Compared to the plants that got nothing, a dose of 100 milligrams per liter boosted the photosynthesis rate by almost 38%. The plant's engine just kicked into high gear. But here's the twist. When they upped the dose to 500, the rate actually dropped by over 10%. It's the perfect example of how more is definitely not always better. And we see an even crazier story with the transpiration rate. Now, that's basically how the plant breathes, how it moves water up from its roots and out through its leaves. That 100 milligram dose caused a massive 81% spike. That plant was just working way, way harder. But, and this is such a fascinating scientific trade-off, while that plant's engine was revving like crazy, its water use efficiency actually went down. So the control plant, the one that wasn't working as hard, was actually being more careful with its water. It just goes to show you the complex balancing act that's always happening inside a plant. So what did the researchers take away from all this? Well, their conclusion was crystal clear. After looking at all the data, they figured out that the 100 milligram per liter concentration, that was the sweet spot. That was the perfect dose for promoting the growth of these young corn seedlings. Okay, so we've seen the science with corn in a lab. But how do we take that and apply it to something we all know and love, like tomatoes? This is the next critical step for any researcher, translating those lab results into a practical, real-world guide for a major crop. And this is where that science becomes a recipe. Agricultural guides, like this one for tomatoes, show us that it's not about just one dose. No, it's a whole strategy. You apply it at key moments in the plant's life. You mix some in the soil before you even plant, you give the seedlings a boost, and then you support the plant again when it's working hard to make flowers and eventually delicious fruit. So you see the thread connecting the corn study in the lab to the tomato guide for the field. It all comes down to this really powerful idea of the optimal dose, what you might call the Goldilocks dose. That corn study is the perfect reminder that in farming, and really in all of biology, you're not just trying to add more of something. You are looking for that Goldilocks amount. Not too little, not too much. You want the dose that is just right to get the best possible result. Just think back to that comparison for a second. The optimal dose gave the plant a boost, but the high dose? It actually stressed the plant out. It slowed down photosynthesis, and it increased something called stomatol limitation, which basically means it made it harder for the plant to breathe and get the carbon dioxide it needs to make energy. So what happens when you get it right? What's the payoff? Well, while that first study looked at the how, another one looked at the final numbers. By using a similar compound on corn, they saw the total yield go up by nearly 25%. I mean, think about that. That is an absolutely massive increase. And that really leaves us with a final, pretty cool thought. The fact that a natural compound applied in exactly the right amount can have such a huge impact on a plant's biology is, well, it's incredible. It really makes you wonder, right? What other powerful secrets are still locked away in the soil, just waiting for us to find the right key?